Come, we talk about the term energy today. So energy is the ability to do work. Energy is the ability to do work. That means if a body is supposed to do work, the body should possess some energy. End of the day. We have discussed this earlier also. If a body, suppose say we have a body, can I have silence please? And if something is bothering you, then keep it to yourself. If you have a body and the body should be having energy with it for it to perform some work. Okay, the body should have energy in it for it to perform work. This is very easy for us to understand. If you as a human being don't have energy, how will you perform any work? Similarly, if you have a body and if you perform work on it, if you do work on it, then the body is said to be energized. Based on these two scenarios, what we can say that energy and work are interchangeable items. Energy and work are interchangeable items. No, not direct. They're just, it's not directly proportional to work. They are interchangeable item. Energy can be converted to work, work can be converted into energy. But when we convert work into energy and energy into work, there are some things which will take care of. So the unit of energy is joules, the unit of work is also joule. So in many problems you will see E is taken exactly as W. E is taken exactly as W because energy is the ability to do work. But one thing which you should also understand that whenever you are doing some work, all energy cannot be converted into work. There will always be losses in the process. Let's take a small example. Like for example, we have got a fuel, petrol. So petrol has what inside it? It has chemical energy. Okay, it has chemical energy, and we burn this fuel. So we develop what? Heat energy. Okay, and finally we are able to rotate wheels. So we develop something called mechanical energy. And these we'll discuss slowly. But as this process continues from chemical to heat to mechanical, all the heat energy cannot be converted into mechanical energy. There will be system losses. There will be heat energy. So we were interested, can all the petrol be converted into mechanical energy? No. There will be heat energy in the process. There will be sound energy in the process. There will be light energy in the process, and these are known as losses. So when we talk about energy is the ability to do work, there are various forms of energy. And this is very primitive discussion that we do in grade 9 level. So let's talk about some forms of energy. The energy due to which you see things moving around, like machine parts moving around, that is called the mechanical energy associated with it. Other forms of energy in this room, electrical energy right now, light energy, kind of or baad mein aata hai. Light energy, easy things. Light, heat. So with heat, potential also, sound energy is there, then tidal energy, wind energy, geothermal energy. So all these are forms of, you use the heat of the earth, it's called geothermal energy. You use wind energy. You can, and the most common forms of energy are heat energy, light energy. A battery uses chemical energy. Then what is the transformation of energy happening when a battery is lighting up a bulb? The chemical energy is getting converted to electrical. Electrical is further getting converted to light energy, right? You are heating up water in a geyser. That means electrical energy is being converted to heat energy. Heat energy, you're heating up. And suppose when you are moving any machine parts, that means the energy and the final energy form is known as mechanical energy, right? For example, you are using your muscles to actually rotate a chakki. So what are you doing? You are using muscular energy and you're converting it into mechanical energy. So since we are in physics and in this chapter we study more about motion and parameters related to motion, the type of energy that our discussion will remain constant to is mechanical energy. So what you understand by mechanical energy? Every machine, every machine and every part. See, is this done in your school? Okay, every machine part or every rotational part that you see, or a moving part may be a part which is sliding, a moving part may be a part which is rotating, a moving part may be a part which is rolling. रोटेट, रोल, स्लाइड, कितने तरह के मूवमेंट्स होते हैं, सब मैकेनिकल एनर्जी है. So our concentration in this chapter will be more on mechanical energy. ठीक है, आइए mechanical energy. And in our syllabus, we study two forms of mechanical energy, one known as potential energy, and the other form is known as kinetic energy. Now let's talk about these two. Our discussion today will be based on these two, potential energy and kinetic energy. Now, mechanical energy is associated with motion. So we will be talking about kinetic and potential energy now. Potential energy, let's first talk about potential energy. Energy possessed by a body by virtue of its position. Energy possessed by a body by virtue of its position. By virtue of its position. So try to understand what happened, Atre. What is disturbing you? You need something. So concentrate here. Energy possessed by a body by virtue of its position. सुनिए इसका मतलब. In Hindi it means what? अगर किसी बॉडी में उसके पोजीशन के कारण एनर्जी है तो उसको हम कहते हैं पोटेंशियल एनर्जी by virtue of its position. Okay. Now let us understand how can position give energy to a body. How can position give energy to a body? So let's take some easy examples and try to understand this concept. Okay. For example, let's say this is a tower, right? And there is a piece of stone which is lying right at the ground level of the tower. There, the ground level of the tower, I have got a piece of stone. Do you expect this stone to fall anywhere from here? Ground level में fall नहीं करेगा, ठीक है? अभी इसी stone को आप rooftop में लेके चले जाइए. Can it fall? Yes. Yes. Then just see. That means this stone is right now in an energized condition. Think about it. Is there a weight on the stone? Yes. The weight of the stone is mass into gravity, which is the force. And say suppose we do not keep, this stone is no more there, and this is my ground level, and say some person is standing out here, and if the stone travels a distance s or a displacement s with its weight, is it doing work? Yes, it is doing work. Fs. It is doing work because it has got energy in it. Have you understood? It is doing work because it has got energy in it. Whenever you are actually, now we'll see a lot of such examples. Energy possessed in a body by virtue of its position. If any body due to its position has any sort of energy in it, then we say that it has potential energy. Now we'll hold the discussion here. Though your book doesn't say, but it is important to understand potential energies are of two types. One is known as gravitational potential energy. One is known as elastic potential energy. What you study more as position is this one, gravitational potential energy. I was here, stone was here, it has no energy, stone has been lifted here. Does it have energy now? Yes, it has got energy now. Okay. Let's talk about elastic potential energy. Look about a bow and arrow. Elastic potential energy means energy by virtue of position. Here the position. Okay, let me make it more interesting. The position here means anything with respect to height. The position here means anything with respect to constraint. Now you will not understand what is the meaning of the word constraint. Constraint means किसी चीज को जबरदस्ती कैद में रखने की कोशिश कीजिए. Okay, let's see a constraint example. I have got a spring which I have somehow compressed like this. मैंने compress कर दिया spring को. The spring in its free form will never be in this way, but you have constrained it. Constraint मतलब हाथ पांव बांध देना. Is it energized? Yes. ठपाक करके खुल जाएगा. Bow and arrow, you stretch the bow string, so it's constrained. Now that is also a position. Initially, where was the position of the string? Here. So there was no energy in the bow. I changed this position, but the change in position is not by increasing the height, but by increasing elasticity or creating a sort of constraint. वॉच, अच्छा बचपन में आपने वो चाबी वाला खिलौना देखा होगा ना, बच्चों को ऐसे चाबी लगा देते हैं, देन डिक 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 चलता है. सो व्हाट आर यू डूइंग व्हेन यू आर वाइंडिंग इट? You, when you wind any toy, you actually wind a film of metal, a strip of metal, and you tightly wind it like this. घुमा दिया है खींच खींच के. Is it energized? Yes. And you don't allow the energy to be released at one slot. धीरे धीरे छोड़ो, तो जब तक ये इसमें एनर्जी है तब तक वो डिग 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 डिग. Have you seen a measuring tape? When we open it, so we have actually constrained it. That's why when you release, ट्रक करके वो वापस चला जाता है. So our book in NCERT or what we learn at grade 9 level, we will be talking only potential energy as by virtue of position, and they will give you all such examples. This position can be due to a height. Though we will be studying all gravitational potential energy, gravitational, we won't study this in grade 9, we study this in grade 11. But you should also understand that potential energy is also has two forms, elastic, gravitational. We will be concentrating on this. Elastic is any sort of energy in a body due to a constraint. Constraint is also a position. Spring's original position is this, you have constrained the spring. Now that is also a new position. Is it energized? Yes, it can now do work. So if you, now, is this example this much getting clear? Going back to our example of gravitational potential energy, now a question comes, though not in your syllabus, try to understand the stability of a system. Stability. A system will be more stable when its energy level is absolutely down. Just think about it. Say, for example, let's talk about this word called stability. If you want something to be stable, that thing's energy level should be very, very less. Let's take a crude example. छोटा बच्चा ले लो. हम कहते हैं ना हमारा छोटा भाई, बहुत एनर्जी है उसमें, सारा दिन भागता रहता है, घर में अफरा तफरी करते रहता है, does all disturbances and all. But at night when the child sleeps, say okay, the mother is most happy. System has come to stable. Why? All the energy inside the body has been drained off. So whenever the energy is high, at that time the stability is less. Let me give you an example. I make you sit on the stand on the top of your school bus's ceiling or on the roof, and I start the bus. As soon as the bus starts to move, you will get so much afraid that what you will try to do, you will say, बैठ जाओ यार roof के ऊपर, खड़े रहने में तो डर लगता है गिर जाने का. ठीक है? And since you are still on roof, then also you will be afraid when the bus starts swirling this side and that side. So given a chance, where do you go? You try to get a seat inside the bus. So you stand inside the bus. Even when you are standing, you're still having more energy. You still have a chance to fall. So you look to sit in a seat. The most comfortable position will be actually the floor of the bus. If you sit on the floor of the bus, at that time your energy level is least. So if you see the vertical height of a body as it increases, you were on the top of the bus, your energy level was maximum, your stability was minimum. ठीक है ना, topple करने से. So therefore, if you go to like old days Bombay, nowadays Bombay has got few double deckers, but earlier when Bombay used to have double decker buses, they will not allow you to occupy the top seats if the bottom seats are vacant, because unnecessarily you are increasing the center of gravity of the body. Are you understanding? नीचे के सीट भरे ही नहीं, आप जाके ऊपर बैठे हुए हो. So the bus's center of gravity has gone on top. As low as the center of gravity will be, the more stable a system will be. Just think a pack of cards. When you make the deck of cards like this and you just touch one card, everything just topples over. But think of one small item. If I right now keep the phone in this manner, is it stable? Unstable. But if I keep like this, the phone is stable. जितना इसका center of gravity नीचे रहेगा, उतना ही stable. So in 1980s and 90s, have you seen a Maruti Omni van? Okay, so the Maruti Omni van that you now see is a typical shape like this. You can go and Google today. This is Maruti Omni van that you see now. But in 90s, there was another van of Maruti Omni, had two models, high roof, flat roof. A lot of high roofs were sold, but a lot of topplings used to happen. Later, Maruti closed this model completely. This model was closed. Either it used to be shown in Hindi movies for kidnapping scenes, because this car is shown, the car comes, crack, the door opens and somebody is pushed inside and the door closes. But this car model, we have seen it in our class 9 and 8, Maruti Omni high roof. but hydrox were later no more, discontinued. The reason for discontinuation of hydrox were that hydrox were no more stable because the center of gravity of the body is increasing. More is the center of gravity on top, the more is your chances of toppling over. You just think keeping something vertically up and keeping something down. So have you understood? What we are trying to talk in this are about gravitational potential energy. This is the potential energy due to vertical height. More a system has energy, more it is unstable. Let's talk about now some more examples. Water comes to our apartment and the water is coming at the ground floor. We can't expect the water to come to our taps directly. So what do? We do work. We are running a motor. We are running a pump and we are pumping the entire water to the rooftop of 19th floor. Are we spending energy? Yes. Electrical energy converted into mechanical energy of the motor and pump, and that is actually taking the water. So where did our electric and mechanical energy go? It got stored as potential energy with that particular water. Now, when you actually turn on the water, do you expect the water to come to our house? Obviously, the water will come to our house because the water has got huge amount of energy stored in it. Yahi pani, if it comes in a waterfall, it will be rotating a turbine and the turbine can also generate electricity. So there what we are doing, we are converting potential energy, which is also known as hydel energy, potential energy of falling water, we are converting into electrical energy. See the beauty of this world. We heat coal, heat energy to make what? Steam. From steam, we are rotating a steam turbine, generating what? Electricity. So from heat energy, we are getting electricity. With that electricity, again, you are heating a kettle of water. With electricity, you are again converting back. So the entire energy of this universe is always constant. Energy cannot be created nor be destroyed. The mass and energy of this universe is constant. If ever you find that energy is depleting, mass must be created. If ever you find mass is depleting, that means energy must be added. So the total of mass and energy is always constant. So let's talk a little bit more about potential energy, gravitational potential energy. So tell me whether you have understood or not as I write some terms now. Potential energy is written as P. Do you understand? The energy possessed by a body by virtue of its position. Such a position can be height or can be constrained. Since we are in grade 9, we are not going to talk about the constraint part. In that, we study a separate object called spring, which we will be studying in grade 11. So here we are going to talk only about gravitational potential energy, and this term together means gravitational potential energy is talked as potential energy in grade 9. Grade 9 में हम GP करके नहीं पढ़ेंगे, मैंने आपको पढ़ाया. But when you talk in grade 9 as PE, PE means GPE. Noodles means Maggie. But noodles can be of 2-3 different types. Okay, potential energy, and this is the energy by virtue of height. So the potential energy PE, its formula is given as mass into acceleration due to gravity multiplied by the height. Mass into acceleration due to gravity multiplied by the height. So PE's formula is mgh, and this will be joules. Why this will be joules? Just check. This is kg, this is meter per second square acceleration, and this is meter. Kg into meter per second square is what? Newton, and Newton meter, but since this is a scalar product, so it will be joules. Is potential energy clear? We will come back to potential energy once we now learn kinetic energy. We'll do one derivation in kinetic energy, and then we will come back to potential energy, do 1 or 2 more derivations and see. Clear? Chaliye. Now we go to the next form of energy, which is known as kinetic energy. So you can ask, sir, are these the only 2 forms? No, no, no. We are studying only mechanical energy. Mechanical energy is the sum of potential energy and kinetic energy. So we call it the total mechanical energy is the sum of the potential energy plus the kinetic energy. This we have already discussed for grade 9. This is mgh. Now we are talking about kinetic energy. So let's understand what is kinetic energy. The word kinetic itself means kinetic theory of matter. Some sort of movement is there. Kinetic energy. Kinetic energy means there is a movement, kinetic Honda. That's right. Kinetic means movement. So this means energy possessed by a body by virtue of its motion. मीन्स अगर कोई बॉडी मोशन में है और मोशन में रहने के लिए अगर उसके पास एनर्जी आ जाता है, then that energy is known as kinetic energy. Kinetic energy is the energy possessed by a body by virtue of its motion. Potential energy was the energy possessed by a body by virtue of its position. Not gained, possessed due to motion. It's not gained. You cannot gain energy. Okay. So if you are talking about potential energy, only potential energy, object must be at rest. And if you are talking about kinetic energy, object must be in motion. यही तो criteria है कि नहीं? If you are talking in terms of potential energy, object must be at rest because it has nothing to do with motion. But if you are talking in terms of kinetic energy, only kinetic energy, then object must be in motion. But what if we have a ball which is actually having a velocity and it is rolling down? What type of energy does this ball have now? This ball will now have a potential energy also and a kinetic energy also because the ball is also at a height from the ground. अगर आप सिर्फ kinetic energy में है, a ball rolling on the ground, it does not have potential energy. It has only kinetic energy. But a ball rolling down a plane, it has some height. इसको तो potential energy भी है और इसके पास kinetic energy भी है. लेकिन जैसे जैसे ये रोल करके आएगा, बड़ी खासियत है, इसकी हाइट क्या होती जाएगी? डिक्रीज होते जाएगा. मतलब इसका पोटेंशियल एनर्जी क्या हो जाएगा? कम हो जाएगा. वो सब गया कहाँ? एनर्जी तो वेस्ट नहीं होता है. It is the conversion into kinetic energy. That's why we say energy can neither be created nor be destroyed, but can be converted from one form to another. As the ball rolls down, what do we expect? The height will come down. So the potential energy, because potential energy is mgh, h will become at this position. What is the value of h? 0. But what is the value of the velocity? Maximum. So all potential energy got converted into kinetic energy. Similarly, let's throw a ball up. We have all kinetic energy, but slowly it is gaining height. As it gains height, gravity will act on it. And as a result, at some place, the ball will attain 0. Is there any motion in the ball now? No. So, but we had given it kinetic energy. Its kinetic energy was going on reducing. Why is the kinetic energy going on reducing? Because it is gaining potential energy. It is getting height. And at maximum height, velocity has become 0. Now the ball has 100% potential energy. How do you prove it? Make somebody lie down and drop it. Dam se girega uske upar. Have you understood? Okay. So kinetic energy. Now we need to get a formula for kinetic energy also. Kinetic energy is the energy possessed by a body by virtue of its motion. Good. इसका formula होता है क्या? Its formula will be, since it is a body, its mass will be coming into play and square of its velocity. Let us check whether this is also joules or not. Half को छोड़ दो. Mass is what beta? kg. Velocity. Okay. Velocity means velocity square. So we can write it as meter per second into meter per second. Right? So kg, take the meter and take the second square. Is this not Newton? This is Newton. Mass into acceleration. This is Newton. And you're left with only 1 meter. Since this is scalar quantity, so this is joule. This is also energy. You don't know dimension analysis now. If we know dimension analysis, we can prove by that also. Did you understand this thing? Kg into meter per second into meter per second. So take 1 meter and take the second square. This is acceleration. Mass into acceleration is force. And meter is displacement. Force into displacement is work. ठीक है? अब देखते हैं derivation of kinetic energy. How do you derive the formula for kinetic energy? Very easy. I don't know whether it's now in your syllabus, but it's quite easy. Okay. So let's understand the derivation of kinetic energy. So let's say okay. Let's say you have a body whose mass is m. First understand, don't write. First understand, then you can be able to write it. There is a body whose mass is m. This body right now has a velocity given by v, means it is moving. This body is in motion. Very good. This body is in motion and it enters into some sort of a medium. This medium can be airy lelo. It is entering into a medium. So whenever a body will enter a medium, the body will encounter drag. There will be a drag on this body. As a result of this drag, say my body is traveling into the medium, a maximum displacement of something like, say the body travels up till this much. The body is traveling up till this much, and then the body comes to a rest. Obviously it has to come to a rest. So let's say the body has come to a rest. Okay, 1 minute. Okay. Sure, yes. The same body, and the body has come to a rest. Its velocity v out here is equal to 0. Clear? While it has come to a rest inside the medium, it has traveled a distance which is given by s, straight line distance, displacement is s. Clear? A body with velocity v and mass m has gone inside a medium, and as it has gone inside a medium, it will be encountered by a drag force. So we should show a drag force also. So let's show the drag force. So this body will be encountered by a drag force, and the force will be acting on this direction. The force is acting on this direction. Ulta act karega. As a result, the body will decelerate. Its acceleration will be negative. It cannot gain speed, and slowly it will come to a rest. By the time it comes to a rest, let us say that the displacement of the body is s. Have you understood? Okay. So we'll say force opposing the body is equal to F. F is the force opposing the body. Do you agree? Now, in order for the body to get inside, right? In order for the body to get inside, it has to do a work which has to be equal to this force. It has to counter this force, and it has to cover this much distance. So let's say, what is the work done by the body? Work done by the body should be equal to the force into displacement. Now you can ask a question that, sir, you had once said that when force and displacement are in opposite direction, the work is negative work. That is if you are considering this force. I am saying body also has to give an opposite force to it, then only it will get inside. This F which I have used is not this F. This F is the F which is created by the body. It also has to counterattack this. And since we are doing scalar work, means we are studying scalar mathematics out here, direction doesn't matter to us. We are only dealing in magnitude. Please try to understand once again. Body is encountering a drag force of F. अगर आपको कोई F drag force दे and still you want to go, don't you think you have to counter that F force from your side? Yes or no? Then what is the work you are doing? Your force into the displacement that you are going. And your force and the drag force, magnitude wise, will always be equal. Direction wise is different. This will be Fs cos 180 only when I am using this force. I am not using this force. I am using the force which ये body velocity के साथ आ रहा है ना, तो ये भी तो force दे सकता है. Body and velocity means it has got momentum. Rate of change of momentum is force. The body can also give a force. This is that force. Have you understood? Now the work done by the body over a distance of s is given by how much? Fs. Is this much clear or not? Itna bolo mere ko. Any doubt you can ask. Anyone, any doubt? Clear? Okay. Now, did I not tell you that work and energy are analogous? अगर ये बॉडी स्टॉप करने तक एफएस वर्क किया है तो इसने कितना एनर्जी स्पेंड किया होगा? एफएस अमाउंट ऑफ एनर्जी इट मस्ट हैव स्पेंट ना. हाउ डिड यू डू दिस वर्क? दैट मीन्स this work done by the body was actually the Ke spent by the body. As I always tell you, if you spend energy, then only you can do work. Have you understood? And when you came here, what about your motion? Your motion is gone. That means your kinetic energy is gone. Kinetic energy is also gone. So हम ये नहीं लिख सकते अभी. That means the Ke of the body should be equal to Fs. इस बॉडी में कितना काइनेटिक एनर्जी है? स्टार्ट में देखो. When you are starting the journey, what is the kinetic energy of the body? Ke. और ये Ke क्या हुआ? ये Ke खत्म हो गया यहाँ पे आके. अगर एनर्जी खत्म होता है तो कुछ वर्क होना पड़ेगा. क्या इसने वर्क नहीं किया? किया ना. There was a drag force opposing me. All my energy I spent to counter that drag force, and somehow by the time my energy depleted, I could come a distance of how much? S. So how much work did I do? Fs. What made me do this work? Because before Fs, I had Ke worth of kinetic energy. इस Ke को मैंने खर्चा कर दिया. Ke घट रहा है, Fs वर्क हो रहा है. तो अगर मैं इस पोजीशन पे इसका Ke निकालना चाहूं, I am interested to find the kinetic energy of the body here. What is the indirect way? Let us measure how much work it has done till here. Okay, giving you an example. I want to measure how much of money is there in your pocket right now. Given the condition that you will spend all your money by tomorrow morning, what should I do? I should just take all the cash memos and invoices of things that you have purchased since morning. उनको ऐड करने से तुम्हारा मनी नहीं आ जाता है. हमें यहाँ इसका पैसा निकालना है. कितना पैसा है इसके पास? तो क्या करेंगे? एस डिस्टेंस तक इसने जितना खर्चा किया सब मेजर कर लो. What is the energy here? The energy here will be spent to cover this distance. So to cover this distance, some work has to be done. If you measure that work, that is the energy here. That's what I wrote. Work done by the body is Fs. Work is energy. So this work was actually the Ke spent by the body from this position. So the Ke of the body is Fs. But our friend has told Ke's formula is what? Half mv square. So how do we get half mv square from Fs? That is our. Which body gains the energy? Here there is no question of gaining energy. He had money in his pocket. He's a spoiled brat. He's spending all the money. So how can he gain energy? He can only gain things. If the body is losing energy, it is doing work, na? Every time it is not possible that if you lose energy, energy has to be. You are considering a scenario where energy is transformed to energy, but we said energy can be transformed to work. When you are burning fuel in your car, who is gaining energy? Work is done on the car. Work is being done on the car. That's why work and energy are analogous, na? If you have energy, the energy is getting transformed into work. अगर वो energy खर्चा नहीं करेगा तो इतना दूर आएगा कैसे? अब अगर यहाँ पे एक spring होता तो आप कह सकते थे, आपका सवाल correct होता, that this thing is actually compressing a spring. So all the kinetic energy is getting converted to what? Elastic potential energy. यहाँ वो scenario नहीं है. Energy to energy scenario can be there. Energy to work scenario. This is energy to work scenario. That's why we say work and energy are always analogous to each other. ठीक है? So kinetic energy of the body is Fs. आवर जॉब इज टू प्रूव इट टू बी हाफ mv स्क्वायर। ठीक है, आ जाओ, f को क्या लिख सकते हैं बेटा, मास इंटू एक्सीलरेशन लिख सकते हैं, लिख सकते हैं। ओके, नाउ यहां पे एक इश्यू है। नाउ व्हेन यू आर टॉकिंग अबाउट एक्सीलरेशन आउट हियर, our acceleration in this case, your force is in this direction, your acceleration will be what? Negative. Your acceleration will be negative. Clear? Force into acceleration, बॉडी की अल्टीमेटली स्पीड जो है वो नेगेटिव हो रहा है। और जरा यहां पे इक्वेशन डालिए तो v square is equal to u square plus 2as. Do you agree? V square is final velocity 0, u square is initial velocity v square, because we have said the initial velocity is v, so u becomes v in this case. Have you understood? Okay, प्लस की जगह पे माइनस लिखूंगा because acceleration is negative, negative into a into s. Agreed? Therefore 2as becomes equals to how much? V square. Agreed? So our s becomes equals to v square by 2a. 2a. Something garbad happened. Now see, a and a will cancel, it comes half mv square. How do you tackle this minus a now? कौन बताएगा? Did you agree what is happening here? Work done is what? Force into displacement. ना v minus u नहीं, अब कुछ नहीं करना है तो आ गया आपका half mv square. A will cancel a, m is there, half mv square. I'm saying why, what went wrong in this minus a? Direction. Now direction means what direction? What? See, there is where your physics should be clear. We said that the work done by the body should be force into displacement, and that force should be equal to what? The opposing force. What is the opposing force? F. And what should be its A? MA. Your work should be equal to that force in terms of magnitude, but in different direction. Ye A, actually this won't be negative A. Sorry, this will be positive A. Force is given by mass into acceleration into this. So this. Oh, this force, see, don't get confused. Force acting on a body is equal to the, if the force is on this side, the acceleration increases on this side. What will the value of this force be? M into A. Acceleration always increases along the direction of force. Consider this force, not the body's force, this force. Then what happens to the acceleration? A. You are finding minus A for this body. Why did you take minus A out here? Why did you take minus A out here? Because you are analyzing the body. The body will undergo retardation. If this body undergoes retardation, then this force should be acceleration on this side, na? Newton's third law में तो दोनों ही action reaction pair है. Are you clear now? Is it confusing for anyone? Do you want me to explain again? This will be MA. So M and M cancels. It becomes half mv square. So understand once again. We have a body of mass m with a velocity v out here when it's trying to enter a medium. Once it enters a medium, it encounters a force, opposing force. The force that acts on a body will be equal to the mass into the acceleration. This force is on this side, so acceleration is this side. This side acceleration for this body is felt as deceleration. That's why here we take negative A. क्योंकि आप v is equal to u plus at, v square equal to u square, or v s equal to ut, you are calculating for what? The body. So please take the A for the body. The A for the body is negative. That's why the body is coming to a rest. Clear? So how do you prove it? You say work done by the body should be equal to the same work done. Work done by the body should be, it has to counter this force. F into S. F is how much? MA. So MA into S. So you just write it Fs, F की जगह पे MA डालो और S को यहाँ से ले आओ, V square by 2A, it becomes half mv square. ठीक है? Further, we get to know that the work done, sometimes at this section you will get problems where there won't be any displacement. Then you will say, how can I calculate work? Work is always F into S. There will be data about velocity. Change in kinetic energy is also equal to work done. ऐसा सोचो, suppose there is a body. Initially, it has a kinetic energy KEI, and then its kinetic energy here is how much? KEF, final kinetic energy. So if we say that if this one is greater, then what is the change in kinetic energy? Delta kinetic energy is kinetic energy final minus kinetic energy initial. This is also equal to work done. And we will get one or two problems where we have to calculate work done based on this formula. You will think, they did not give us force, they did not give us displacement. How can we calculate work? What can be calculated by this formula also? अब कुछ problems करें based on potential and kinetic energy. ठीक है? Are we clear? चलो, अब कुछ problems करने की कोशिश करते हैं. Easy problems first. So before you start the problem, remember the formula. Kinetic energy is equal to half mv square. Potential energy is equal to mgh, and work done is equal to force into displacement. Remember this. The first question, calculate kinetic energy of a body. They have told you that the mass of the body is equal to 2 kg. Okay, and it has a velocity, and the velocity is 0.1 meters per second. Calculate its kinetic energy. Very easy. कैसे करोगे? K is equal to half mv square. So it's half into 2. V, how you will write? Never do by point. 1 by 10 into 1 by 10. So 1 by 10 into 1 by 10 is how much? 1 by 100. So its kinetic energy should be 0.01 joules. 0.01 joules. Understood this one? ये तो easy है. Okay. यहाँ पे एक और चीज आपको कभी-कभी पूछता है. Look at kinetic energy. It's half mv square. Now this definition is very interesting. If you double the mass, what happens to the kinetic energy? It gets doubled. If you double the mass, because say this is our initial kinetic energy. Our final kinetic energy is what? We have doubled the mass, half into 2m into v square, which is half into, we bring this 2 outside, to mv square. Can I not write this as half into k initial? जरा देखो तो क्या लिखा मैंने? मास को डबल किया तो 2 को बाहर ले आया, and rest of the expression is half mv square, which is the initial kinetic energy. So if you double the mass, the kinetic energy doubles. If you double the velocity, what will happen? 4 times हो जाएगा, because velocity पे square है. Then the kinetic energy will become 4 times. देखोगे, Ke initial is equal to half mv square. Ke final is half m. V को हमने क्या कर दिया? 2v कर दिया. Double the velocity. 2v square. 2v का square करोगे तो कितना हो जाएगा? 4. So keep the 4 outside and retain half mv square here. So this is 4 into Ke initial. So if you double the mass, the kinetic energy is doubled, and if you double the velocity, the kinetic energy is now some more interesting things. If the mass is made half, then the kinetic energy becomes half into half mv square it will be. But if you half the velocity, the kinetic energy will become 1/4. अरे ये तो straight linear relation है ना. Velocity बढ़ेगा. Think me running to you and elephant running to you with full speed. Who has more kinetic energy? The elephant. The elephant has more mass, more velocity than me. It's running. Therefore, it was very, very lethal in Indian warfare. Na? When Alexander first time came to India, the first thing he saw was elephants using in battles. उसने कभी ग्रीस में कभी देखा ही नहीं था. Such a big. Now, if you can watch, there's a very nice, although it's in cartoon and animation, there's a Kurukshetra which has come on Netflix. I've done it nicely. The voices are from Amitabh Bachchan in the starting. They have got the 18 days are shown in 18 episodes. I will ask you all to watch them. It's done in animation, but up class animation. Hai. I'm watching every day. So there you will see when the elephant is made to strike somebody, they will actually scratch the elephant or put one nail inside the elephant, give it pain, then the elephant becomes ferocious. चोट लगाना उसको तो वो और जाके हमला करेगा. Plus when the elephant falls, it's a huge mass. तो ठीक है. So if you halve the velocity, the kinetic energy becomes 1/4. ये question आता है लेकिन. So based on that, let's take a question. It says two bodies of equal mass. Two bodies of equal mass. Very nice. This is a body. Its mass is m. This is a body. Its mass is also m. But they move with velocities v and 3v. They're moving with velocity v and 3v. तुम दोनों का क्या है रे पेन लेके लफड़ा? क्या प्रॉब्लम है अत्रेया? एक बार बोल दिया जब छोड़ दो ना. Whether you're in fault, what is that great affinity for that pen? क्यों एक बार मैं बोला ना? नहीं है. Whose pen is it? Yours na? Keep it with you. Next day he will bring a pen. Yeah, बच्चों जैसे यार, you're all getting to grade 10 now. Okay, V and 3V. The question says, find the ratio of their kinetic energy. Ratio will always be a number. No, you have to find the ratio of their kinetic energy. So let's say this is body 1 and this is body 2. Find out what is kinetic energy 1. Ke1 is equal to half mv square. Very easy. What about Ke2? Ke2 will be equal to half m 3v square, which becomes 9 times of half m v square, which is 9 times of Ke1. Now they've asked you to find the ratio. So ratio is very easy. So you can write 1:9 means you have to write it like this. Ke2 by Ke1 is equal to 9 by 1, or you can say Ke2 is to Ke1 is equal to 9:1, or Ke1 is to Ke2 is equal to 1:9. Either way is correct. ये समझ में आया? तो यहां भी इसको करने की जरूरत नहीं, आप डायरेक्ट दिमाग लगा सकते हैं, क्योंकि वेलोसिटी को आपने 3 गुना किया, 3 का स्क्वायर हो जाएगा. When you double the velocity, kinetic energy increases by 4 times. So V2V में रेशियो कितना आएगा? 4:1. V3V में कितना आएगा? 9:1. V4V में 16:1. हाँ, ये ट्रिक है, ऐसे मैच किया जाता है. 5 value 25:1. Understood? Okay, let's take next problem. Our next problem is interesting. How much work should be done on a bicycle? So we have a bicycle. How much work should be done on a bicycle? And the bicycle's mass is 20 kg. How much work should be done on a bicycle to increase its speed from 3 meters per second? Okay. No, 2 meters per second, sorry. 20 kg, you want to increase the speed from 2 meters per second to 5 meters per second. Now look at the question, very interesting. They are asking, इस bicycle में work करना पड़ेगा ना, pedal मारना पड़ेगा जोर से. How much work you need to do to increase the speed from here to here? यहाँ वही logic काम आएगा. The work that we need to do, we will do on this bicycle. So bicycle will gain equal amount of kinetic energy because its velocity will increase, right? So the change, so what do we say? The change in kinetic energy of the bicycle should be the work that I will be doing. ये bicycle अभी कितने रफ्तार से जा रहा है? 2 meters per second. मैं इस पे कोई work करूंगा, मेहनत करूंगा, तो इसकी स्पीड कितनी हो जाएगी? 3 meters per second. ये kinetic energy बढ़ेगा? बढ़ेगा. क्यों बढ़ा? मैंने वर्क किया और मुझे यही पूछ रहा है आप कितना वर्क करोगे। तो वर्क का प्रॉब्लम क्या होता है, फोर्स इनटू डिस्प्लेसमेंट, बट नो फोर्स एंड डिस्प्लेसमेंट डेटा आर हियर, सो वी हैव टू अटैक दिस प्रॉब्लम फ्रॉम काइनेटिक एनर्जी साइड। हाउ मच मनी वाज विथ Tekbir? We are not allowed to check his wallet. What we will do, we will check all the invoices of item that he bought, add them up, that is his money. Another way of finding. So let's see the change in kinetic energy. Tell me, what is the change in kinetic energy? It will be Ke final minus Ke initial. Now there's a trick to do this problem. How? Half m v square minus half m u square le lo, initial velocity u. Clear? So from here half m can be taken as common, v square minus u square. Take your algebra, half m v plus u, v minus u. Now put all your data. Half, what is the value of m? 20. V plus u, 2 plus 5 is how much? 7. And v minus u, 5 minus 2 is 3. बस हो गया आपका। कितना हो गया? This will make it 10. 7 3s are 21. 210 joules of work you have to do in order that the vehicle's speed increases from 2 meters per second to 3 meters per second. ये समझ में आया? तो it is simple. जेनेरिक फॉर्मूला में क्या आप डायरेक्ट भी कर सकते हो, आपकी मर्जी। Clear? Okay. We'll see some problems of potential energy, but when you do problems in potential energy, some things that they will trick you are like this. See, a man climbs stairs and he is reaching a place. ये हाइट नहीं होता है, हाइट यही होता है हमेशा। Height is vertical. Don't get carried away by this. This is what is needed for your problems. Remember that. Okay? So shall we do some potential energy problems? What is the formula of potential energy? mgh. So let's take some problems on potential energy. So it says acceleration due to gravity g they have given as 10 meter per second square, and further they say what will be the potential energy of a body is mass is 1 kg and kept at a height of 5 meters. डूब जाओ, ये सब तो क्वेश्चन है। ये कर पाओगे कि नहीं सृष्टि? Potential energy is mgh 50 joules. P is equal to PE is equal to mgh. Just check the units. m कितना है? 1. g कितना है? 10. h कितना है? 5. That means 50 joules is the potential energy. Okay, next question. A bag of wheat weighs 200 kg. यानी कि हमारे पास इस बार क्या दिया हुआ है? Mass is equal to 200 kg. A bag of wheat weighs 200 kg. To what height should it be raised? Height नहीं पता. So that the body's potential energy is 9,000. The PE is equal to 9,800 joules. अब बोलो इसमें G का वैल्यू क्या लेने बोलेगा आपको? 9.8 लेने बोलेगा। देख के समझ में आ रहा है। So take G as 9.8 and you can find out the height. Okay, एक छोटा derivation देखेंगे, though not required for you, but it will clear up. Our next thing is power, but it will clear up your idea about what happens, and that will be the most interesting thing with which you'll leave the class today. Okay, ये निकल गया? You will be able to do it this, right? कितना? Half meter. Half meter निकाला है. Ananya's answer is half meter. What is the answer? Hey, 5 meters है answer. क्या गलती किया? P is equal to mgh. So h is equal to P over mg. हाँ बस हो गया फिर. 9,800 divided by 200 into g. G is 9.8. ठीक ही तो है. 1000 हो जाएगा ऊपर। चलो चलो चलो, ये छोड़ो, नया चीज देख लेते हैं और फिर आपको छोड़ते हैं। डन, चलो रब इट। ओके, नाउ दिस इज एक्चुअली अ ग्रेड 11 सिनेरियो, बट इसको देखते हैं, मजा आएगा आपको, आपको समझ में आ जाएगा, कोई प्रॉब्लम नहीं है। सो लेट्स टेक अ हाइट, लेट्स टेक अ हाइट एंड लेट दिस हाइट, दिस टोटल हाइट बी h। ये टोटल हाइट कितना है? h है। देखो इसमें मजा आ जाएगा। एंड लेट्स हैव अ बॉल and this ball's mass is how much? m. What is the energy at this position? What energy is there at this position? Potential energy. This ball is allowed to drop down, so once it comes to the ground, ये ground पे आ जाएगा। इस वक्त इसका potential energy क्या हो जाएगा? Zero। और हम क्या कहते हैं? Energy can neither be created nor be destroyed। अगर हमारी बात करेक्ट है तो at any time the energy of the body should be constant. Shall we check? तो कितना मजे से चेक होगा? We will check the energy of the body at 3 places. 1, some arbitrary place 2, and right at the bottom 3. We will check what is the total energy of this body. Are you ready? आपको लिखने की जरूरत नहीं, आप just मजा लो। At 1, what about the velocity of the body? 0. Therefore, what is the kinetic energy of the body? 0. What about the potential energy of the body? It is mgh. Do you agree? So what is the total energy of the body at 1? Please don't pack pencils and rubbers. Listen to it. Otherwise it disturbs me. Just listen to it. Give me 5 minutes. The total energy at 1 will be given by potential plus kinetic. So the total energy is how much? mgh. Is this clear? Let's check the energy at 2. At 2, let us say that the body has traveled a distance of x. Body has traveled a distance of x. So how much is the body's height from the ground? Who can tell me this? h minus x. Body's height is h minus x. So at 2, let's calculate what is the potential energy. mg into h minus x. Do you agree? This is the height now. This is given by mgh minus mgx. Clear? Okay. What is the kinetic energy of the body at this place? At this place, the body will acquire, यहां से यहां तक body आ गया है. So what is the, we need the velocity at this point. The velocity v square will be equal to u square, which is 0 square, initial velocity, plus 2 into g into how much distance it came? X distance it came. This is the kinetic energy of the body. This is the v square. So v square's value is how much? 2gx. So kinetic energy is equal to half m v square, that is 2gx whole square. ठीक है ना? Oh sorry, v square itself is 2gx, so it's just half m into 2gx. Do you agree? So half and half cancels. What is the kinetic energy of the body? mgx. Find out what is the total energy of the body at 2. Potential plus kinetic, mgh. Telling. Let's come to the bottom. At 3, the height has become 0. Therefore, potential energy is 0. Velocity has become maximum. So kinetic energy becomes how much? Half m v square. अच्छा, आपको विश्वास नहीं होता है velocity कितना होगा? चेक कर लो. The velocity here, v square should be equal to u square, initial velocity 0, plus 2gh. 2gh, because it has come a distance of 2gh. So let's put that formula out here now. Let's put that formula. Kinetic energy is equal to half into m into v square. What is the value of v square? 2gh. This cancel. It is mgh. Find out what is the total energy. Potential is 0. Kinetic is mgh. So the total energy is mgh. At all 3 places, the total energy of the body is mgh, which clearly proves energy is neither created nor destroyed. At every position here, all I had was potential. As soon as I am losing potential, I am gaining kinetic. Potential goes away. finally I have all kinetic, my potential has become 0. गन को जब हम कॉक करते हैं तो we have pulled the spring, potential energy, and when you just press the trigger, the potential energy is released, everything is converted into kinetic energy. हाँ, कुछ नहीं होगा, ठीक है. The problem is you getting more reacting to it. आप 5 मिनट छोड़ दो उसको, आपको कुछ नहीं होगा. वो आप उससे बड़े हो, शरीर से बड़े हो, काया से बड़े हो, उसको दांत नहीं है, वो आपसे डर रहा है, आप नहीं. इसी को तो कहते हैं, कौन सा बोलो बेटा, एक कौन सा, ये नहीं, ये है काइनेटिक एनर्जी एट पोजीशन 2. पोजीशन 2 पे v स्क्वायर की वैल्यू क्या है, 2gx. सो हाफ m v स्क्वायर विच इज 2gx. 2 ने 2 को काटा तो क्या हो गया, mgx. ठीक है, तो फिर यहां पे टोटल करेंगे तो कितना आएगा, mgh माइनस mgx प्लस mgx. ये दोनों कट गया, हमारे पास क्या रहा, mgh. ये एक्चुअली ग्राफ में देखोगे तो as kinetic gains down, potential climbs up, so the total energy anytime remains same. ये आपको 11 में प्रूफ करने देगा. ये आपको इतनी महान कुछ तो है नहीं, लॉजिक है.